Right, this is 27.3, covering pages 521 to 526. Have you ever wondered why the sky is blue, why sunsets are red, why clouds are white, and why water is that blue-green color? Well, today we're going to answer those questions. So why is the sky blue? The sky is blue, really, the reason is because of selective scattering. So what happens is the light coming from the sun enters our atmosphere, and when it does, the atmosphere is transparent to most of the light, and it's not as transparent to ultraviolet or infrared light. So when the light hits our atmosphere and the atoms and molecules in there, as it's being remitted, as it's transmitting through it, it scatters the light in all directions, right? So it breaks that light from the sun apart. So what happens is that the violet light is scattered the most, and that red is scattered the least. So the red comes through without being like bounced around. The orange comes through, the yellow, the green. So the violet is scattered the most when it enters the atmosphere, and red is scattered the least, and everything in between, right? So our eyes can't really see violet as well. So the next thing that is scattered the most is going to be the blue. The blue is scattered, and so we see the sky as being blue because that's what our eyes are sensitive to, right? Our eyes don't have cones that are sensitive to violet. They're sensitive to red and blue and green. So we see the blue best, and that's why the sky looks blue to us. So the sky really isn't blue. The sky would actually be more purple. We just weren't made with our eyes. God didn't make our eyes so that we could see the purple as well as we see the blue. So next time somebody asks you, you can say, actually, the sky is purple. And then you can have a little argument with them. And the reason is because of selective scattering. The violet, because of the wavelength, is scattered more than the red. The red is able to get through easily. And the things at the lower end of the spectrum are able to get through easily. So the scattering, we are able to see the blue being bounced off from the light waves. Now, that blue is going to appear different depending on location and atmospheric conditions. If you've ever noticed, some days that sky is bright blue and some days it's kind of pale blue. So clear days where the atmosphere is dry are going to have deeper blue than humid days. The more humid it is, there's more water molecules in the air to scatter it more. And so the more scattering you have, you get a little bit of that green being scattered as well. Our eyes are going to see it more pale because we don't see the blue as well because of the green being scattered. But on dry days where the green is able to come through and the blue is scattered more than the green, it's going to appear deeper blue. So if there are a lot of particles that are larger than the oxygen and nitrogen that are normally in the air, the low frequency light is going to be more scattered. And the more scattering you have, the more white it's going to appear, because remember, all of the colors together make white. So the more you have in the air, besides just your small oxygen and nitrogen atoms, the more scattered the light will be, which will make it appear more white. So in areas where there's a lot of smog, there's even more light scattered, and the sky will start to take on a brownish haze just because of the other molecules that are in the air. So why are sunsets red? Selective transmission. So remember, the light is getting scattered. Some of it is getting through and some of it isn't. So the light that isn't scattered is transmitted. So if the blues and the purples are being scattered, then the reds aren't really being scattered. They're getting to come through. So then why isn't the sky red all the time if the red light is getting through? Well, what has to happen is that it has to be at a certain level in where the light rays are coming into our atmosphere, have to be at a certain level in order for it to be transmitted correctly. So when it is traveling through the thick atmosphere as sunset and sunrise, the atmosphere is a little thicker, the sun's a little farther away from it, there's more time to scatter the high frequency light. So as the sun is going down or as the sun is coming up, the high frequency lights are being scattered even more, so they're out of the picture. And what makes it through the best is going to be the reds and the oranges and the yellows. So that is why sunsets are red. The more particles you have in the air, the more it scatters the blue and the violets and the greens and scatters them. So the sunsets then, if you have more particles in the air, are going to be even more bright and vibrant and colorful. So places where there's a lot of smog, tend to be that their sunsets are going to be a little brighter, a little more colorful. Also, places where you've got a lot of like dust particles in the air can tend to have very bright and vivid sunsets. So like over deserts, out in West Texas where I grew up, we had amazing sunsets because of the dust that is in the air. It scatters the high frequency waves more and lets the reds and the oranges come through. So why are clouds white? Well, if the sky is blue because of selective scattering and the sunsets are red because of selective transmission, the clouds are white because of scattering as well. So what happens is the water droplets that are inside the clouds are going to be different sizes. And the different sizes of water droplets are going to scatter the frequencies differently. So if you have the tiniest little water particles are going to scatter the blue, the medium ones scatter the green, and the bigger particles are going to scatter the red. Well, if you're scattering red, blue, and green, what we see then is white light. So remember, the sky looks blue because it's scattering the blue and not the red and green. The sky starts to look on a whitish appearance the more particles you scatter. If you start to scatter blue and green, it's going to start to appear white. Well, if you scatter blue, green, and red, the clouds are definitely going to be white. So if you have really big droplets, they start to absorb light and not scatter it, and that's what makes the clouds look dark. So then if the drops get too much bigger than that, then they become too heavy and they will fall out of the clouds. So you've got your white clouds because you've got large, medium, and small particles inside that are scattering all the light, making them appear white. These clouds start to look dark, rain cloudy, remember cumulonimbus clouds, because the water particles are getting so big that they're absorbing all the light and don't let it through. And then when they get bigger than that, then they're going to start to fall. So why is water bluish green? Well, that bluish green, the actual term for it would be cyan. So if you look at any lake or ocean, it looks like it's a really deep blue. It's not actually blue. The water is not really blue. It is actually just a reflection of the sky. So in places where you've got a really nice deep blue sky, your lake or your ocean is going to appear blue. So the real color of water is actually that cyan color, that bluish green color. So normally water is transparent to pretty much all visible frequencies. Water is actually kind of clear. The more water you have, though, it's going to absorb the red end of the spectrum. So water is transparent to visible light and some ultraviolet light, but the infrared is absorbed. And once it absorbs the infrared, it can also absorb parts of the red spectrum. So what happens when you take red away from white light? You're left with blue and green. So white light minus red is cyan, which is that blue-green color. So water appears blue-green, even though it's really clear. It appears blue-green because it absorbs the red a little bit out of the white light. Right, that's all for color. So there's no quiz tonight. Get ready for a test pretty soon. Have a good evening, and I'll see you later.